What if training a sophisticated robot wasn't a tedious laboratory chore, but a video game that people actually wanted to play? The authors of the paper RoboCade explore this exact possibility by gamifying robot data collection. Scaling robot learning faces two massive walls. You typically need expensive hardware right in front of you, and honestly, the work is incredibly boring. Current methods require thousands of repetitive demonstrations, which quickly burns out human operators. To solve this, the researchers introduce RoboCade. Their core idea is gamification, taking the mechanics that make video games addictive and applying them to the dry task of remote robot teleoperation. The system is built on specific design pillars intended to trigger a state of flow. It offers immediate visual feedback like confetti for successes, along with long-term progression systems involving avatars, badges, and leaderboards. Crucially, they don't just dress up the boring work, they introduce support tasks. Instead of sorting electronics, a user might play a game matching toy animals, which secretly teaches the robot the same fundamental grasping and placement skills needed for the real job. Let's look at how this setup translates into physical hardware and actual performance metrics. This diagram shows the complete loop. A user manipulates a low-cost 3D printed controller called gello, and those movements control a real Franca FR 3-arm thousands of miles away through a browser-based game. When actual humans tried this platform, the engagement data was positive. In a study with 18 participants, users rated the gamified system 27% more intuitive and 24% more enjoyable than standard control interfaces. But fun doesn't always equal function, so they tested the robot's learning too. Co-training models with this gamified data improved success rates on the actual target tasks by anywhere from 16 to 56%. This figure highlights that performance jump across 3 different tasks. By mixing the gamified support data with real data, the diffusion policy models learned significantly more robust behaviors. The most significant takeaway is that gamified data helps robots handle the unexpected. The models showed up to a 48% improvement in handling novel starting positions, proving that crowdsourced gameplay can build more adaptable artificial intelligence. To learn more, head to emergentmind.com.